Hello guys, you're welcome to my channel. Today we want to talk about surd. What is surd? Okay, we are all going to understand what is surd and how to carry out an operation that involves surds in mathematics. But before then, I would like us to recall some characteristics and some definitions of numbers. Now, when you talk about real numbers, these are numbers that we can represent or we can see on a number line. Now, when we talk about this, we can talk about the natural numbers. We can talk about the whole numbers. We can talk about the rational numbers, or before the integers. We can talk about the rational numbers. We can talk about the irrational numbers. All these numbers, they are real numbers. So when you talk about natural numbers are those numbers that we regard as a counting number, whereby we have 1, 2, 3, 4, and so on. And we have the smallest natural numbers to be 1, while we don't have the largest natural numbers. Then whole numbers are the set of natural numbers including 0. So we have what? The smallest whole numbers to be 0, while we don't have the largest whole number. Integers are set of whole numbers including their negatives. So when you talk about negative numbers and positive numbers, you talk about what? Integers. Then where we really need to focus on as regard this topic, surds, is rational numbers and irrational numbers. So when you talk about rational numbers are those numbers that can be expressed in the form m over n, where n is not what? 0. So any number that you can express as what? m over n, where n is not what? 0, then we can say this is what? This is a rational number. Example of rational number: whole numbers are rational numbers, integers are rational numbers, natural numbers are also rational, because if I have 1, I can express 1 as 1 over 1, I can express 2 as 2 over 1, and so on. So if I have 2 over 3, this is also what? A rational number. Okay, there are some rational numbers that we might not have them like this. When you have a number with non-terminated and what? Repeated decimal. Non-terminated and repeated decimals are also rational number. For example, if I have 1.333333, this continues till infinity. So this is what? This is a rational number, because I can write this as 1.333 and half by there. So this is a rational number because this is equivalent to 4 over 3. So that is what we call rational number. Specifically, number that you can express as what? M over n. Some textbooks will say it is what? Number that you can express as P over Q. Whichever one, they are still correct as well, provided that the denominator is not a surd and it's not also what? 0. Okay. Then irrational numbers. Irrational numbers are those numbers that we cannot express as what? M over n. You can express irrational number as m over n, even if n is not what? 0. Are we together? And also we can say irrational numbers are those numbers with non-terminated and non-repeated decimal. For example, I have pi, the exponential, the square root of 2, square root of 3, and so on like that. They are all examples of irrational number. Now, there is another number that I would like us to look at before we now go into the main topic, what we call surds. Now, when you talk about what? Another number, we have what we call prime numbers. the prime numbers. When you talk about the prime numbers, these are numbers with two factors, whereby we have what? The two factor to be 1 and itself. So when a number have just two factors, which are 1 and itself, we say that number is a prime number. So I'm not dealing with number theory here where I'll be considering the negative factors as well. No, we are not looking into that now. So we are only considering the positive what? The positive factors only. So when a number has what? 1 and itself as a factor, that number is said to be a prime number. An example of prime number include 2, 3, 5, 7, and so on like that. 1 is not a prime number because the only factor it has is itself, so it's not a prime number. And the only even number that is a prime number is 2. Are we together? The only even number that is a prime number is 2. Now we can now define the term surd. Okay, class, when you talk about surd, what is surd? Surds are square roots of prime numbers. Surds are square roots of prime numbers. So when I say square root of prime numbers, example includes the square root of 2, the square root of 3, the square root of 8, the square root of 6, and so on like that. All these are examples of a surd. Now, you will question me that I said surds is the square root of a prime number, but is 8 a prime number and also is 6 a prime number? They are not prime number, but they are the product of prime numbers. In other words, I can write my 8 as the square root of 2 times 4. And this implies 2 root 2. If you look at the surd I have there, it is what? The square root of a prime number. And when you look at 6, the square root, the 6 is written as 2 times 3, which I can write as root 2 times root 3. These are prime numbers. So when you say surd, surd is the square root of a prime number. Now, there are rules that bind what? Carrying out an operation under what? Surds. And what are those rules? I have my first rule to be, if I have, for instance, I have square root of 9 times the square root of 16. This is just the same thing as saying 3 times 4, and my result is going to be 12. Also, I can say the square root of 9 times the square root of 16 is the same thing as saying the square root of 144. So the square root of 144 is giving me as what? 12. Hence, I can conclude that the square root of A times the square root of B is the same thing as root AB. This is the first rule of surd. Okay, if I also have something like the square root of A divided by the square root of B, this can be the square root of A over B. Okay, if I also have A root B, okay, A root B plus C root B, this is the same thing as saying A plus C times root B. Also, if I have A root B minus C root B, the same thing as saying A minus C root B. All together. So these are what the rules of surds. Also, if I have the square root of A times the square root of A, my result is going to be what? A. Are we together? Okay. Mind you, if I have A root B plus C root D, this is not the same thing as saying A plus C times root B. Why? Because root B, I don't have B to equal to what? To D. So once we don't have the same thing under the surd, that is, when the surd are not similar, we cannot add or subtract them together. Are we together? Okay? If that should be the case, let us consider what we call basic surds. What are basic surds? Basic surds. So I'm not going to be using a difficult terminology or definitions of vocabulary in this class so that we can understand. When you say a surd is a basic surd is a surd whereby you can no longer simplify it. That is, if you express the number under the root as a product, none of its products can have a perfect square. Do we get what I'm saying? When you express the number under the root, none of what the numbers that you express as its product can have what? A perfect what? Square. That is, if I have something like this, if I have root 2, this is a basic surd. This is also a basic surd. This is a basic surd. But if I have root 8 is not a basic surd. Likewise, root 18 is not a basic surd also. Why? Because root 8, I can write it as the root 8 is a product of 2 and 4. And you know 4 has a perfect square. Hence, root 8 cannot be what? A basic surd. But if you look at root 6, the root 6 is a product of 2 and 3. 2 does not have a perfect square. Likewise, 3 does not have a perfect square. Hence, root 6 is a basic surd. Now, for this one to be in basic surd, I have to write this as 2 root 2. Do you understand that? Because I can split this one as root 2 times root 4. And root 4 has a perfect square, which is 2. So I will have 2 times root 2. That will give me what? 2 root 2. Now, root 18 is not also what? A basic surd. Why? Because I can write root 18 as 9 times 2. So 9 times 2 is the same thing as saying root 9 times root 2, and that will give me 3 root 2. Hence, this is a basic surd, and this is also a basic surd. Do we all understand what is called a basic surd now? Okay, if yes, let us look at another concept of surd which we call similar surd. Similar surd. When you say surds are similar, what we are simply talking about is that they all have the same numbers under the root. Simply that. Okay? When you say similar surds are, if I have root 2, if I have 3 root 2 and 4 root 2. So because 2 is equal to 2, these two surds are similar. If I have 4 root 3 and I have root 3, these two surds are similar because 3 is equal to 3. So when you have the same root, the same number under the root, we said those surds are similar surds. But if I have something like 3 root 2 and I have 3 root 3, this is not a similar surd because 3 is not equal to 2. Are we together? So if you look at this, this is 2 and this is what? 3. So they are not similar. So you can also have similar surd in another way, which is different from this. If I have something like the square root of 8, I have the square root of 18. These two surds are similar. Okay? How are they similar? They are similar because if I write this one in its basic form, I will have 2 root 2. And if I write this one in its basic form, I will have 3 root 2. So they both have the same surd at the under the root rather. Are we there now? So they have the same number under the root. That's why root 8 and root 18, they are also similar surds. Are we together? Okay, if that should be the case, I can now what? Consider another concept which we call the simplification of Surds. Simplification of Surds. Okay, now that we have understand the concept of basic form, the similarity of a surds, then we can carry out operation on that surds now. Let's look at example 1. Okay, example 1 says simplify the square root of 20 plus the square root of 45 plus the square root of 125 minus the square root of 2 minus 2 root 80. Okay, class, this is what they asked us to simplify. The square root of 20 plus the square root of 45 plus the square root of 125 minus 2 root 80. So, the first thing we should understand is that all these surds, they are not in their basic form. So, the first thing to do before we carry out any operation is to reduce everything here to their basic form. Okay? So, root 20, I can write it as 4 times 5 plus root 45, I can write it as 9 times 5 plus root 25, 125, root 125, I should be able to write it as 25 times 5 and minus 2 roots. This is 80, I should be able to write 80 as 16 times 5 if I'm not mistaken. Okay, if that should be the case, okay, well this give us 80, 5 times 16, 5 times 6 that's 30, we have 0, 4, 5, so that's 80. Okay, if that should be the case, I can continue by saying this one is the same thing as saying 2 root 5 plus this one is 3 root 5 plus this is going to be 5 root 5 minus what? This is going to be 4. 4 times 2, that's 8 root 5. So they are now what? In their basic form. Now that they are in their basic form, the next thing to consider is the similarity between them. Are they all similar? If yes, let us carry out the algebraic operation. This plus this will give us what? 8, and plus this, that's going to give us 10. So we have 10 root 5 minus 8 root 5. Hence, 10 minus 8 is going to give us what? 2 root 5. And that will be the result for this surd. Do we understand this? Should in case everything are not similar, but some are similar, so we'll deal with the ones that are similar and leave the ones that are not similar. Is that taken now? Let's look at another example on this. Okay, example 2. If I have 3 root 2 minus the square root of 32 plus the square root of 50 plus the square root of 98. Okay, the first thing we should do, class, is what? Is to reduce everything to basic form, right? Okay, this one is already in its basic form, so we have it to be 3 root 2, nothing changed, minus, this one is not in its basic form, so we have 16 times 2, and this one is going to be 25 times 2 plus, this will be 49 times 2. Are we together? Okay, if yes, this is the same thing as saying 3 root 2, nothing changed, minus 4 root 2, agreed, and this will be 5 root 2 plus this will be 7 root 2. Okay, they are now in their basic form. The next thing to consider is what? The similarity between them. So they are all similar because they have the same number under the root. So we can carry out the operation by taking the addition first. 3 plus 5, that's 8, plus 7, that's 15. So we have 15 root 2 minus 4 root 2. And this will give us 11 root 2. I believe we understand this. Okay, if that should be the case, let us quickly look into what we call conjugate so that we can have more solution or more problems to deal with under this simplification. So the next thing we have to look at now is conjugate. Okay, conjugate of surd. Okay, what do you understand by conjugate? Okay, like I said, we are going to take this class to be in a simple what? In a simplest manner. Okay, look at something. When I talk about a conjugate, conjugate is a number that you use to multiply another number to get a rational number. Conjugate of a number is another number that you use to multiply that number to get what? A rational number. Okay, you seem not to understand what I'm saying. Let's take for instance that I have a plus b to multiply a minus b. You know, this will give me a square minus b square. That's what we call difference of two square, right? Okay, if this gives us this, now let us consider this irrational number a and this irrational number b, and this irrational number a minus irrational number b. You know, this is going to give me this. I'll have the square root of a all square minus the square root of b all square. If that should be the case, this and this would cancel, and this and this would cancel. Hence, the square root of a plus the square root of b times the square root of a minus the square root of b is a minus b. Okay, you will see now that these two numbers, they are irrational number. Abi? Now, our result is what? Is rational. Hence, the conjugate of this is going to be this. And the conjugate of this is going to be this. Because whenever you multiply the two together, our result is going to be what? A rational number. Do we understand what we call conjugates now? Okay? If you understand what we call conjugate, what will be the conjugate of root 2 plus root 3? You can pause the video and give me an answer. Okay? And pause the video now. Your conjugate is going to be the square root of 2 minus the square root of 3. Do we understand what is called the conjugates now? Okay? If yes, let's proceed to look at some examples under this. But before we look at some examples under this, how we like us to consider what we call rationalization. Rationalization. Okay, class, when you talk about rationalization, okay, when you talk about rationalization, you all understand that irrational numbers are those numbers that we cannot express as m over n. That is, you cannot find them at the denominator. Now, the only thing we can find at the denominator are the rational numbers. So the process of making an irrational number to become irrational, that is what we call rationalization. For instance, if I have a over root b as a given question. This is wrong mathematically because you can't have an irrational number at the denominator. Hence, all I need to do is to rationalize. How do I rationalize? Okay, this is how to rationalize. The surds that you have at the denominator, you have to use it to multiply both numerator and denominator. So, this is like multiplying this by 1. So you've not changed anything mathematically, right? Okay? A times this will give us what? A root b. And root b times root b, remember the law, our result is going to be b. Hence, this is what? A rational number now. Are we together? So, we have just rationalized this function. Are we there? So, you can see we don't have what? A surd at the denominator again. That is what we call rationalization. Okay, what if you now have something like a all over root b plus root c? Okay, for us to rationalize this, we are not going to take the same process like this, but we are going to take a similar process. For us to rationalize this, you remember, there's an algebraic sign between this and this. Hence, we need what? The conjugate of this one to make it a rational number. Hence, we are going to multiply the numerator and denominator by the conjugate of the denominator. So we have root b minus root c divided by root b minus root c. So this will give us a into bracket root b minus root c divided by this times this will give us b and this times this will give us c. Hence, we have successfully rationalized this. Okay, what if I have it in another form? Like I have a divided by b plus the square root of c. Or let me say minus. Okay, if I have a divided by b minus the square root of c, I will also rationalize by looking for the conjugate of this because the entire function here is irrational. Are you getting it now? So, I have to multiply the numerator and denominator by the conjugate of the denominator. Hence, this will give me a into bracket b plus root c divided by b times b, that's b squared, and this will become minus what? C. So, this will be our result. Okay? Now, let's look at some examples under what? Under this, before we call it a day on the said topic, rationalization, or the topic entirely solved. Okay? Okay, now let's look at the examples on this. Okay, example 1, we are told to rationalize the following. Rationalize the following. The 3 plus the square root. Okay, I think this marker is not writing well. We have to rationalize 3 plus the square root of 2 divided by root 5 plus root 3. Okay? This is the same thing as asking us to simplify this question. Okay? The first thing we should ask ourselves is, what is the conjugate of the surds at the denominator? Okay? The conjugate of the square root of 5 plus the square root of 3 is the square root of 5 minus the square root of 3. Hence, 3 plus the square root of 2 divided by square root of 5 plus square root of 3. We have to multiply this by the conjugate. Do we get this? Okay? This now will multiply this. So I have 3 plus root 2, the root 5 minus root 3, divided by this times this will give us 5, and this times this will give us minus 3. Abi? Okay? Let's continue here. So this times this will give us 3 roots 5, and this times this will give us minus 3 roots 3. Okay, we are done with this. So this now will be plus the square root of 2 times the square root of 5 is going to give us root 10. And this times this will give us what? Negative root 6. Are we together? Okay, divided by 2. Okay, now let us try to rearrange this so that we can have something that will make sense there. So this will be 3 root 5 plus root 10 minus 3 root 3 minus root 6, all divided by 2. All these surds are already in their basic form. That is, there's no how we want to express them that one of what their factors is going to have a perfect square. 10 is just 2 times 5 or 10 times 1. And also 6 is just 6 times 1 or 2 times 3. Hence, what we can do now is, I can write this as 3 root 5 plus root 5 times root 2. Are we together? And this will be minus 3 root 3. Are we together? Plus root 3 times root 2. Okay? All divided by 2. So root 5 is common here, so I can factorize it out. I will have root 5 to be 3 plus root 2. And here also root 3 is common. I can factorize it out. I will have root 3 into what? Into 3 plus root 2 divided by 2. Now that what I have in the two brackets is the same thing, so it means we can have the results to be the square root of 5 minus square root of 3 times 3 plus root 2 all over 2. And that will be our results for that question. We can't do further than this. Is that taken? Okay, let's look at another example. Okay, another example here states that if I have 1 plus root 5 divided by 1 minus root 5, we are asked to simplify this by rationalizing it. Okay, so we just multiply by 1 plus root 5 divided by 1 plus root 5. Hence, this times this will give us 1 plus root 5 plus root 5 plus 5 divided by 1 minus 5. Abi? Hence, this plus this will give us 6 plus 2 roots 5 divided by minus 4. 2 is common here. If I factorize it out, I have 2 into what? 2 into 3 plus the square root of 5 divided by negative 2. Sorry, negative 4. So 2 here 1, 2 here is what? 2. Hence, our result is going to be 3 plus root 5 divided by 2. Multiply by the negative sign. So that's just going to be our result. Do we understand this now? Okay, let's look at one more question before we call it a day. Okay, this kind of different from what we have been doing before. Okay, we have the question here. The question says express 8 minus 3 root 6 divided by 2 root 3 plus 3 root 2 in the form m root 3 plus n root 2, where m and n are rational number. Okay? This is the question given to us. We are asked to express 8 minus 3 root 6 divided by 2 root 3 plus 3 root 2 in the form m root 3 plus n root 2, where m and n are rational numbers. Okay? Let's see. Solution to that. Okay? Let's forget about the other part of the question. Let's focus on how to simplify this. 8 minus 3 root 6 divided by 2 root 3 plus 3 root 2. So let's find the conjugate of the denominator. So that will be 2 root 3 minus 3 root 2 divided by 2 root 3 minus 3 root 2. We haven't changed anything, right? Okay? This and this will multiply. That's 8 minus 3 root 6 to multiply 2 root 3 minus 3 root 2. All divided by this times this. 2 times 2 will be 4. Then 4 times 3, that's 12. Then this now times this will be minus. 3 times 3 is what? 9. Then root 2 times root 2, that's 2. 9 times 2, that's 18. Are we together? Okay, let's continue here. 8 times this will give us 16 root 3. And 8 times this will give us minus 24 root 2. We are done with this. So let's pick this next. This times this will give us minus 6 root 18. Are we there? And this times this will give us plus 9 root 12. All divided by negative 6. I don't want to do anything like mathematics pro so that you can understand what we are talking about. Okay? If this should be the case, all these surds are not in their basic form. Let us make them to be in their basic form. This is already in its basic form, so 16 root 3 remain. This is already in its basic form. 24 root 2 remain the same. Root 18 is the same thing as 3 root 2. This time this will give us negative 18 root 2. And this is the same thing as saying 18. The root of 12 is the same thing as saying 2 root 3. Yeah. So times 2, that's 18. 18 root 3 divided by negative 6. Okay. If this should be the case, we can collect the like terms. 16 plus 18 is going to give us what? Okay? That should give us 34 or 36 if I'm not mistaken. No, that should be 34. This plus this will give us 34. So 34 root 3. And this will also give us what? So this is going to give us 42. So we have 42 root 2 divided by negative 6. Let's confirm our addition. So 16 plus 18, that's 34. 24 plus 18, that's 42. Correct. Okay, if this should be the case, we cannot add or subtract these two together. Okay, can 2 go here? Yes. Can 2 also go here? Yes. Okay, this should give us 17 root 3 minus, this will give us 21 root 2 all over negative 6. Hence, if I multiply both numerator and denominator, sorry, this is going to reduce to 3 because we have divided through by 2. Sorry. So, multiply through by the negative, we are going to have 21 root 2 minus 17 root 3 divided by 3. Hence, this will become 21 root 2 over 3 minus 17 root 3 all over 3 as well. So this can become 7 root 2 minus 17 over 3 root 3. So in other words, we have to leave our answer in the form of m root 3 plus n root 2. So we have to invert the answer. So our answer, our result is just going to be negative 17 over 3 root 3 plus 7 root 2. Hence, m is equals to negative 17 over 3 and n is equal to 7. So this will be the end of the class today. We'll meet in the next class where we'll be talking about the square root of surds. Do have a nice day.